Okay, let's look at 2.1.2. This is a nice question. Not something that we see every day, but practice questions like these are normally your higher order questions, but it's still easy. Okay, before we maybe delve into the question, let's just think back to one of our exponential laws. So let's say you got maybe a multiplied by b, and all of this is squared, right? When we expand this, what does this look like? Okay, so we know that there are invisible ones here. We know that this one multiplies with both of these exponents, right? So we know that when you expand this, it ends up being a squared times b squared, right? So over here we have two different bases. Okay, so let's just look at this. Here's a base a, here's a base b, so two different bases, but their exponents are the same. So this exponent, the exponents are the same. Different bases, your exponents are the same. So if you apply this exponential law backwards, when you have different bases and your exponents are the same, you can multiply those two bases together and have your exponent on the outside. How does this help me? Okay, let's actually deal with the question that we've got. All right, so our question, we have a plus square root of 2a minus 1, and all of this is being all of that is under a square root, right? So I'm just going to rewrite this, and I'm going to make this to the power of a half, because we know square root means to the power of a half, right? And then there's a dot there, so we know it's multiplying, and I have a minus square root 2a minus 1, and all of this also to the power of a half, right? Just thinking back to that exponential law that we spoke about, different bases, right? So this base, different bases, however same exponent. So what did we say? We said those bases can multiply and then have that same exponent. So we can rewrite this as a plus square root of 2a minus 1, and this is going to multiply with a minus square root of 2a minus 1. Okay, so those two things are going to multiply, and then outside them we will have this exponent half over there. Great, so that helps. Why does that help? Because now, okay, this is a right now when we look inside our brackets, you look inside this bracket and you look inside this bracket, what do you notice? Hopefully you notice something. You notice that your values are the same, but the sign in the middle is different. That rings a bell. That looks like a difference of two squares. So if you want to go multiply everything out, go ahead. But for us that knows that's a difference of two squares, we know we will have the first one squared, so it's going to be a squared minus the last one squared. So that in our case now, that's going to be the 2a minus the 1, right? And that's going to get, well, the square root would have been squared, so the square root disappears. And don't forget we had the square bracket thing over here, which had this half outside. Okay, let's see if we can simplify this further. Right, so this is going to give us a squared. Let's take this negative inside, so it's minus 2a, and that's going to become a plus 1. I'm going to change this exponent back to the root form, so all of this is under my root. Hopefully we are still okay. Okay, so I'm going to just write over here so that I don't lose that. This under my root, okay, that's a trinomial. Hopefully we can recognize that trinomial. So let's factorize that trinomial. Let's go two sets of brackets. The coefficients of that a squared term is 1, so we know we can go with a and a. This is also a 1, so our only options are 1 and 1. That's a plus, so we have to have same signs. This is a minus 2, so both our signs will be negative, and all of this is under our square root. Okay, so this is going to simplify as square root of, our brackets are the same, so it's a minus 1. All of that gets squared. Our square root and our square cancel out, so our final answer is going to be a minus 1. Right.